Next, we're going to use our general formula for the derivative of an inverse function to compute explicit formulas for the derivatives of the inverse trig functions, namely arcsine, arccosine, and arctangent. Now, these derivative rules actually are kind of a little bit surprising because the derivatives of the inverse trig functions can be expressed in a way where that doesn't involve trig functions whatsoever. So it's a little bit of an interesting result. So let's start with the derivative of arcsine. So suppose we want to compute the derivative of arcsine of x. So here our original function, so we can define f of x is equal to sine of x, and then the inverse function is arcsine of x. So sine of x and arcsine of x are inverse functions of one another. So when computing the derivative of the inverse function of sine, we can use our general rule. And our general rule states that f inverse prime of x is equal to 1 over f prime of f inverse of x. Right, so that's our general rule that we derived in the previous section for derivatives of inverse functions. So basically here, f inverse is just the arcsine function, and then this left-hand side is just the derivative of the arcsine function. So this formula gives us exactly what we're after. So we need to, and then f inverse on the right-hand side, so the input here is just f inverse. So for us, that's just going to be arcsine of x. So all we need to really do is compute f prime. Well, if f is sine of x, we know that f prime of x is equal to cosine of x. So the conclusion is that the derivative of f inverse, so in other words, the derivative of arcsine of x is going to equal 1 over f inverse, well that's cosine, evaluated at, or f prime is cosine, evaluated at f inverse of x, so it's cosine of arcsine of x. So this is the derivative of the arcsine function. But it doesn't end there because there's a nice algebraic simplification we can do with the right-hand side that derives from the identity cosine squared plus sine squared is equal to 1. And in fact, let me call this cosine squared of y plus sine squared of y for a reason that will be apparent in a moment. So therefore, we can express cosine of y. So you see what we're doing. I'm going to replace y with sine inverse of x. Cosine of y in general is the square root of 1 minus sine squared of y. So therefore, cosine of sine inverse of x is going to be the square root of 1 minus sine squared of arcsine of x. But remember, sine squared is just sine of something quantity squared. So this is really the same as square root of 1 minus sine of arcsine of x quantity squared. But sine of arcsine of x is just x. Remember that the inverse function undoes the original function. So sine of arcsine of x is x, so this just becomes square root of 1 minus x squared. So cosine of arcsine of x, interesting trig identity, is equal to the square root of 1 minus x squared. So that means, and that's exactly the denominator right there. So the implication of this is that we get a derivative rule our first derivative rule for inverse trig functions is that the derivative of arcsine of x is equal to 1 divided by the square root of 1 minus x squared. So that's a great rule to start with. So this is our general formula right here. So we derived the derivative of the arcsine function. Let's see, erase all of that. Okay, so next let's do the same thing except for the arc cosine function. So now let's take a look at, well, what if f of x is cosine of x? And so we want a derivative rule for f inverse of x, which is arc cosine of x. Okay, well, the derivative of cosine is negative sine. So this general formula tells us that the derivative of arc cosine of x is equal to 1 over f prime, so that's 1 over negative sine, evaluated at f inverse, so negative 1 over sine of cosine inverse of x. Now we can apply the same sort of trick to simplify this further. So sine of y is equal to the square root of 1 minus cosine squared of y. Now when I replace y with arc cosine of x, cosine of arc cosine of x is just x, so therefore sine of arc cosine of x just becomes the square root of 1 minus x squared. So our next formula is the derivative of arc cosine of x is just equal to minus 1 over the square root of 1 minus x squared. So interesting result. So with this general formula, we've managed to derive formulas for the derivative of the arcsine function as well as the derivative of the arc cosine function. And they are kind of surprising, right? The derivative of sine was cosine, derivative of cosine was negative sine. Usually when you differentiate a trig function, you get a new trig function. Not so with these inverse trig functions. Derivative of arc sine is just of x is 1 over square root of 1 minus x squared. Derivative of arc cosine of x is negative 1 over square root of 1 minus x squared. So an interesting development. Okay, so next let's conclude with the arctangent function. So if we have f of x is equal to tangent of x, f inverse of x, of course, is the arctangent function, and f prime of x is secant squared of x. So we all know that the derivative of tangent is secant squared. So this, let's see what we get. So the derivative of arctan of x, so this is the derivative of the inverse tangent function, it's going to be 1 over f prime, so it's going to be 1 over secant squared evaluated at f inverse, so secant squared of tan inverse of x. So what can we do to simplify this one? Well, the same trig identity, so recall that sine squared of y plus cosine squared of y is equal to 1, breeds a new trig identity that's valid for tangent and secant. So if we just divide this equation by the cosine squared of y, well, sine over cosine is tangent, so we end up with tangent squared of y plus cosine squared of y divided by cosine squared of y is 1, so plus 1. And then 1 over cosine squared of y is just equal to secant squared of y. So the secant squared of y is 1 plus tangent squared of y. Therefore, secant squared of arctan of x is just going to equal 1 plus tangent squared of the arctan of x. Now tangent of arctan is just of x is just x. So this is the same as just 1 plus x squared. So therefore we get our final derivative rule for the inverse trig functions. And that derivative rule is that the derivative of tan inverse of x, or the arctan of x, is 1 over 1 plus x squared. So those are the derivatives of the three basic inverse trig functions. And they all stem from this general rule for computing derivatives of inverse functions.